This is the lecture for lesson 15. As we continue working with functions, we're going to start with graphing absolute value functions. One option you have to graph a function is, of course, to plug it into a graphing calculator. There is Desmos, or if you have a handheld one, any of those will work. Other option is to just start plotting some points. Now, do know that an absolute value function is always going to be in the shape of a V. So you always want to make sure that you find that turning point and you have both sides of the V on your graph. So for this first one, if we are just going to plug in some values, I'm going to have you plug in -2, -1, 0, 1, and 2. We need to, there we go. Sorry, the font started to fade away. So I'm going to plug in the absolute value of -2 and then add 3. Well, the absolute value of -2 is 2. 2 plus 3 is 5. Now I'm going to do the absolute value of -1 plus 3. Well, the absolute value of -1 is 1. 1 plus 3 is 4. Absolute value of 0 is 0 plus 3 is 3. Absolute value of 1 is 1. Add 3 makes 4. And the absolute value of 2 is 2. Add 3 is 5. So I'm going to plot those points and then connect them to make my absolute value graph. So -2 is up at 1, 2, 3, 4, 5. -1 is at 4. 0 is at 3. And then 1 goes back up to 4. And 2 goes back up to 5. So I've gotten both sides of the V, and that is my graph. So one thing to notice is when you add a number on the outside here, it shifts your graph up. If I were to subtract a number on the end, it's going to shift my graph down. And those are things that we'll talk about a little bit further into the class. All right, this next one, we have a 2 outside, and then inside we have a +4. So those are each going to do 2 other things to our graph. I'm going to give you the points to plug in for this one. So let's do -8, -6, -4, -2, and 0. All right, so I want to do 2 times the absolute value of -8 plus 4. Well, -8 plus 4 is -4. And then I want to do 2 times the absolute value of -4. The absolute value of -4 is 4. 4 times 2 is 8. 2 times the absolute value of -6 plus 4. Well, -6 plus 4 is -2 inside the absolute value. Absolute value of -2 is 2. Times by 2 is 4. Now we're going to plug in -4. So 2 times the absolute value of -4 plus 4. Well, -4 plus 4 is 0. So 2 times 0 is 0. Now we're going to plug in -2. So 2 times the absolute value of -2 plus 4. Well, -2 plus 4 is going to give me 2. 4 minus 2 is 2. Absolute value of 2 is 2. Times by 2 is 4. Which means this next one should give me my 8. If I'm following that pattern here, 5, 4, 3, 4, 5. So I go down to my V, my turning point, and then back up. I go 8, 4, 0. I see 4 again. So then 8 should be the next one. They should always be symmetric. So we can double check. 0 plus 4 is 4. Absolute value of 4 is 4 times 2 is 8. So starting at -8 here, 1, 2, 3, 4, 5, 6, 7, 8 is out there. And it's going to be one more above, so it's out there. -6 is at 1, 2, 3, 4. -4 is at 0. -2 is at 4. And 0 is up here at 8. So the two things that happen here, the number in front changed the slopes of these lines. So they're a little more, a little steeper. And then this guy here shifted the graph to the left. Again, those are things we'll talk about a little bit later as we work on some more graphs. All right, the last one we're going to graph here is the absolute value of x plus 5, and then minus 2 on the end. So again, for this, I'm going to give you the values that we're going to plug in. I'm going to do -7, -6, -5, -4, and -3. So the reason I know where to start is based on what's inside here. Your turning point is going to be where that inside equals 0. So x plus 5 equals 0 gives me x is -5. -5 is going to be that turning point. And then so I want to go 2 below that and 2 above that. All right. Absolute value, -7 plus 5. And then we want to subtract 2. So -7 plus 5 is -2. The absolute value of -2 is 2. And 2 minus 2 is 0. -6 plus 5 in the absolute values, and then subtract 2. So -6 plus 5 is -1 inside the absolute value. Absolute value of -1 is 1. 1 minus 2 is -1. Now plugging in -5 plus 5 is going to give me the absolute value of 0, which is 0 minus 2. -2. -4 plus 5 inside the absolute value bar is -2. Well, -4 plus 5 is 1. Absolute value of 1 is 1. Minus 2 is -1. And we found that turning point. So 0, -1, -2, back to -1. This one's going to be 0. So if we graph that, 1, 2, 3, 4, 5, 6, 7 is at 0. -6, -1. There. Okay. And that is my absolute value graphs. The next set of graphs are called toolkit functions. These are your lines, your parabolas, and your cubes. So your x graphs, your x squared graphs, and your x cubed graphs. You can, again, use a scientific calculator, or we can just plot some points and graph them. So this first one wants us to graph the function -3x plus 5. If it is just an x, this is going to make a line. So we are going to grab a few values here. Let's do 0, 1, and 2. I plug in 0. -3 times 0 is 0. Plus 5 is 5. If I plug in 1, -3 times 1 is -3. If I add 5 to that, I get 2. And then if I plug in 2, -3 times 2 is -6. If I add 5 to that, I get -1. So again, plot your points. So 0, 1, 2, 3, 4, 5, 1, 2, and 2, -1. Once you have a few points, you can connect them, and your graph is done. The next graph is x squared minus 4. So again, we'll pick some values here. We'll go from -2 to 2. If I take -2 and I square it, that makes 4. 4 minus 4 is 0. Next one, if I take -1 squared, I'm going to get 1. And subtract 4 from that, I get -3. I plug in 0. 0 squared is 0. Minus 4 is -4. Plug in 1. 1 squared is 1. minus 4 gives me negative 3. This one's going to follow that same kind of repeated opposite pattern, but it's not going to make perfect lines. It's going to make more of a U-shaped graph, up or down. All right, 2 squared is 4. 4 minus 4 is 0. So negative 2, 0. Negative 1, negative 3. 0, negative 4. And then symmetric on the other side. So an x squared graph is going to look like a U-shaped graph. It is called a parabola. And then the third graph, x cubed plus 2. Those are the cube graphs. Cube graphs look like one of these two. Again, we're going to go on either side of 0, negative 2, negative 1, 0, 1, and 2. All right, negative 2 cubed is going to give me negative 8. If I add 2 to that, that gives me negative 6. Negative 1 cubed is negative 1. Add 2 to that gives me 1. 0 cubed is 0. Add 2 is 2. 1 cubed is 1. Add 2, you're going to get 3. Then 2 cubed is 8. Add 2 to that is going to give you 10. So we plot them, negative 2, negative 6, negative 1, 1, 0, 2, 1, 3. And then 2 times going to be kind of up here. Connect your points with a smooth curve. The next thing we can talk about with graphs is the domain and range from the function as well as from the graph. When we are given a function, there are a few limits that happen on x. The first is if we have a fraction. In a fraction, we know our denominator can never equal 0. So if our function has a fraction and the variables in the denominator, that is going to limit the x values that we can use. The other one is if we're talking about a square root. Okay, our square root, we cannot, with real numbers here, have a negative under the square root. So what's under the square root is called the radicand. And our radicand must be greater than or equal to 0. So looking at the first function, 2x plus 5. There's no fraction. There is no square root. So there's going to be no limits on x. And when there's no limits on x, our domain is all real numbers. I can plug any value into this equation and it's going to work. When I look at b, I have 1 over x plus 9 plus 3 over x minus 10. So I have not just one fraction, but two fractions. And those denominators cannot equal 0. So in b, x plus 9 cannot equal 0. X minus 10 cannot equal 0. So I need to solve those. If I solve those, moving the 9 over by subtraction, x cannot equal negative 9. And then for this one, to get rid of minus 10, I'm going to add 10. So x cannot equal 10. Or x cannot equal negative 9. So I can plug in any other value except for negative 9 and positive 10. Now, there is another way that you can write that. And that would be in the interval notation. So all real numbers, let me go back to that first one, is going to be negative infinity to infinity. All right, so for this one, we cannot use -9. So I can go negative infinity up to -9, but I can't include it. So it's going to have the open parentheses. I can then have any value from -9 to 10, again, not including them. And then any value from 10 on up to infinity. Personally, I prefer just to write it like this. It's a little bit easier than it is in interval notation, but depending on your homework, I just wanted to show you both ways. And the last one we have here is the function is the square root of x minus 3. So what that means is what's underneath the square root has to be greater than or equal to 0. So x minus 3 has to be greater than or equal to 0. If I solve that, I will add 3 to both sides. X has to be greater than or equal to 3, which means that we can include 3 and go to any number on and on in the positive direction towards infinity. So the next part is going to have us find the domain as well as the range for the graphs. So domain is your x value limits. The range is the y value limits. Is there a limit at some point that causes us not to be able to use a y value? So some things that may happen here are asymptotes, and that's going to be in B. We have asymptotes. Or we just have a graph that starts at a certain spot and can't go past a certain value. So this one is your fraction type graph. This one is your square root type graph, and this is just a line. A line does not have any limits on it, so both the domain and the range are going to be all real numbers, or negative infinity to infinity. Looking at B, the domain is looking at the x values. So when I look at the x values, there is kind of this invisible line here that the graphs do not cross. This one goes down towards it, and then on the other side, the graph goes up towards it. So it is looking like x cannot equal -1. Positive 1. That's on the positive side. So what that would mean, I could go negative infinity up to 1 or 1 to infinity, but I cannot include 1, which is why it is in a parentheses and not a bracket. If there's going to be a limit on the x, there's also going to be a limit then on the y values, which is your range. So the range, it looks like here is then this horizontal line. It looks like we do not cross the axis here or the y value of 0. So y does not equal 0. And that means we can go from negative infinity up to 0 or 0 up to infinity, but we cannot use 0. And this last one, our square root graph, our domain. Well, here's where the graph starts. So that's the smallest x that I can use, which according to the graph is -4. So I can use -4, and I can go forever to the right in the positive direction, so towards infinity. Now your range, now you're looking at your up and down values. So you start at a y value of 0, and then the graph goes up. It's going to go up, 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 up. It's continuing to go up forever and ever. So the range is going to be from 0 to infinity. The next type of function is called a piecewise function. A piecewise function is going to be composed of at least 2, sometimes there's more than 2, different functions to create your overall graph. And then what they will do is they'll tell you where the function changes. For this first one, we have this function is going to follow 6x minus 1 for any x value less than 0. And then it's going to follow 7x plus 3 for any x greater than or equal to 0. If I want to find the value of f of negative 3, well, negative 3 is less than 0, so I'm going to use the first part of the function. 6 times negative 3 minus 1. 6 times negative 3 is negative 18, minus 1 is negative 19. For the second part, when it says plug in f of 0, well, the equals to 0, because 0 is the changing point, the equals to is down here. So to evaluate f of 0, I have to use the second function, 7x plus 3. So 7 times 0 is 0, plus 3 is 3. It's just a matter of making sure you know which function you should be plugging into based on your limits. The next function is going to follow x plus 5 if x is greater than or equal to negative 5, and the opposite of x plus 5 if x is less than negative 5. Plugging in f of 0. So 0 is bigger than negative 5, greater than. So we're going to use this first one there. So 0 plus 5 is going to give me 5. Now the second one, f of negative 6. So negative 6 is smaller than negative 5, so I'm going to use the second equation, the opposite of negative 6 plus 5. So I need to do negative 6 plus 5 first, and that's going to give me negative 1. And then we want to take the opposite of negative 1. Well, the opposite of negative 1 is 1. Now, the last part of this lesson is going to talk about some properties that happen in our functions, such as increasing and decreasing intervals, local extrema, and then absolute maximums and minimums. Given the graph below, find the intervals in which the function is increasing and decreasing, if any. Anytime your graph is moving up from left to right, that is an increasing interval. And anytime it's moving down from left to right, that is a decreasing interval. So if I want to look at my increasing sections, that's going to be from here to here. That's going up. So that's negative 5 to negative 4. And then the next section is decreasing. So from negative 4 to negative 2, my graph is going down. So I'm going to put that in the decreasing. Then it turns and goes back up. So negative 2 to the x value of 0. Remember, you're only listing x values. So negative 2 up to 0. I'm going to put a u between there. Then we switch to decreasing again. So from 0 to 2. 0 to 2. Then we go back increasing from 2 to 4. And then back decreasing from 4 to 5. So it's just a matter of listing out increasing, decreasing, increasing, decreasing, increasing, decreasing based on the x values. Next graph wants us to do the same thing. The difference on this graph is we have arrows on the bottom here, which means that this graph is going to continue to go down and to the left forever and ever. And on this side, it's going to go down and to the right forever and ever. So hold on, increasing, decreasing. This first part, if I start here, and remember the arrows there, so it's going to go forever. So it's going to start at negative infinity, and the line is going up until an x value of 0. Then it switches to a decreasing section until I hit this spot here, which is the exact middle of 1 and 2, so 1.5. So we're decreasing from 0 to 1.5. Then we switch back to increasing, so 1.5 to 3. And then we switch again down to decreasing, remembering the arrows there, so 3 to infinity. We can also have what are called local maximums and local minimums in a function. And what you're looking for is where the graph changes direction from positive to negative or increasing to decreasing. Like this is going to be a local maximum. And if I go decreasing back to increasing, this is going to be a local minimum. So they want us to find those points and list their coordinates. When I look at this first graph here, that is a turning. I go from decreasing to increasing. That is a minimum, and it is located at an x value of -1, a y value of 0. Following the graph, the increase turns into a decrease at that peak there, and that is a maximum then at the x value of 1 and the y value of 4. We have another graph here. Wants us to do the same thing. So any bottoms or peaks or valleys, that's what you're looking for. So maximums, minimums. If I'm looking at this, the maximum is this guy up here, 0, 1. Then your minimums are the valleys. So that's over here at -1, 0. And another one here at +1, 0. In addition to local maximums and minimums, we can have absolute values for absolute max and mins. Now, this means the absolute highest that the graph goes in a given window or the absolute lowest that it goes. For graph 5, it wants us to find the absolute maximum. So that means what is the absolute highest value that this graph will go to. And if you are looking at the graph, the high point is here. So I no longer want locals. I don't want all of the ups and downs. I want just the highest up or down. So in this case, maximum, the highest up. So that value is going to be, so the point is -2, 4. So what that means is the maximum is 4 at x equals -2. And then for 6, we want to find the absolute minimum. So you find the absolute lowest point, there's only one. It is at the point 4, -4. So the minimum is -4, the y value, at x equals 4. And that is the end of that section. You can work on the homework.